Hi, today I'm going to talk to you about the SPDY protocol. The SPDY protocol is an addendum onto HTTPS, which is already just an addendum onto HTTP. It added the security layer, which SPDY does the exact same thing, except for it adds another layer called the session layer. So it takes from HTTPS in that way. And a typical HTTPS use case is you send a request, you get this back, and this will be a document that you requested. The document will then have links to other documents, such as CSS files and JS files, that you need to go through the HTML and parse, and then you need to go get each of those out. And the way that you do that is you make a TCP connection for each request that you want to make. Now, what is the problem with this? All of these TCP connections can be run in parallel, right? The problem is that only 6 connections per domain in Chrome is the highest amount of connections that any browser allows. So that means if you have more than 6 documents, you have to wait, which is bad because a lot of websites such as Facebook and Twitter use a lot more than 6 documents because they're very image intensive. Also, you can't push any information to the client, so the client has to ask for the information before you can actually give it to them, which is bad for real-time data such as news feeds and friend requests. Also, there's no header compression, and also most of the compression is generally optional, even though Chrome does make you use it. And we use the same headers over and over and over again, which means we're sending more packets unnecessarily. So where does SPDY fit in? Right in the middle between HTTP and TSL. It's called a session layer. And what's in this session layer that they've implemented? The biggest feature is multiplex streams. So multiplex streams are a way of allowing one TCP connection to act almost as many TCP connections by creating virtual streams over which you send data. And this allows us to then have long pole connections, which means we can talk to a server for a long period of time and then send the request over that same connection. So we don't have to reconnect at any point, so we're saving time and packets. Also, it's implementing a server push because it's tracking where the user is and what the user is doing. It can actually send things to the user that the user hasn't requested yet. And it can also use the same information to reduce headers in their redundancy, because headers are often the same value for request after request. We shouldn't have to send the same headers over and over and over again. And finally, they made sure that data compression was required, because data compression leads to less packets. So how do multiplex streams work? First, you have to understand framing. Frames are basically chunks of data that are sent from the server to the client with different types. So one type is send reply, one might be a send stream or a send receive. These are implemented in the SPDY protocol. Now, a send stream is going to allow you to create a new stream between the client and the server, or the server and the client. And the number of these streams are unlimited, which means that you can have as many as you want, send as many things as you want over one TCP connection. And they all are handled on their own process on the server, and they can be handled on their own process on the client, which means they can all run in parallel. Server push is a great thing because it allows us to implement security over HTTPS for connections, while also allowing the server to give information to the client fast. And it does this by sending in information to the client immediately, saying, here are all the resources that I'm going to send to you, and then the server tries to create all of these different streams, and the client can choose to accept those streams or not, and if it does, it can get the data. Now, SPDY browser support is much better than you would expect. It's Chrome, Firefox, IE, however, no Apple Safari yet, which is interesting, despite IE being there. But Google, Twitter, and Facebook are all using these on the back end now, and Apache and Nginx are supporting it, which means up to 60% of the web could easily switch to mod SPDY doing the same things that I did in my implementation. Speaking of my implementation, the way that I did it was I have a website that I created a long time ago called Facebook Chat Analysis, which has 33 to 37 different resources that it has to go get just to work. And so what I did is I timed this over HTTPS and over SPDY to see if I could see a noticeable difference. So since it's over Apache, what we're going to do is explain the Apache pipeline, which is one HTTP handler per socket, whereas the SPDY Apache pipeline is multiple handlers per one socket. And they do this using this thread pool that you can see down here at the bottom, and still using mod SSL. So what are the results of me going to this webpage? The results are that the first 11 resources, almost 12, were all extremely fast for SPDY. And this is because Chrome is actually in charge of doing things to make SPDY faster and doing the correct requests. Whereas the next, after 12, all of those were much slower because most likely they are using require.js, which is a way of asynchronously getting your JavaScript and managing dependencies, which might not work well with SPDY, and actually has not been tested. I tried to look up a lot of articles on it, and there wasn't a lot. But it might actually be defaulting to HTTPS because require.js doesn't know how to use SPDY yet. Even though most of the resources were actually slower with SPDY, the total speed up from those initial speed ups was actually significant, 0.17 seconds on average over 15 trials versus 0.20 seconds. And overall, I mean, Speedy was just faster. So it's interesting to note that even though some of these things weren't quite as fast, the initial page load and everything was much faster, and you could see how this could scale. 17 seconds versus 20 seconds is a big deal.